Okay, looking at some problems here in 2.4 and 2.5, which encompass the product rule, the quotient rule, and the generalized power rule. Okay, and these are three pretty tough rules to use sometimes because we can construct pretty big functions by multiplying, dividing, or raising a simpler function to a power. Okay, and that's what these three rules tell us, and should be about all you need in those sections of homework for the real derivatives, in addition to the the rules we've already talked about. But here we've got a function called f of x. This is a problem similar to 2.4 number 7, which you would have seen in the WebAssign homework. The function was called x to the 5th minus 6x times 5 over x squared. So even though this function is called f of x, it's really a product of two functions. Okay, so if we're going to use the product rule, in the product rule you notice that they call the first one f of x and the second factor g of x. So, that's the f of x in the product rule, that's the g of x in the product rule. The name of this function doesn't really matter, but it happens to also be called f of x. So, okay, we want to find the derivative of this, so we have to use the product rule. Okay, and that product rule says take the first function times the derivative of the second plus the second function times the derivative of the first. Okay, that's how it's written in the book. Sometimes I write it a little bit differently because I've seen it in different forms in other books I've used, but okay, so what did they say here? The first function times the derivative of the second. Okay, so that's x to the 5th minus 6x, okay, times the derivative of the second. Well, now that I look at it again, I say, well, maybe it's going to help to rewrite it a little bit. Okay, that's the first function. But 5 over x squared, I can write that as 5 times x to the power negative 2. Okay, and the reason I'm doing that is, if I don't do that, I probably need the quotient rule here. But since it's just 5 divided by x to a power, I can write it as 5 times x to a negative power. And that's helpful because, again, the quotient rule says the first function times the derivative of the second. Well, here we can just use that ordinary power rule we talked about in 2.2. Okay, so if we have to find the derivative of 5x to the power negative 2, okay, of course the constant 5 can be factored out. And then we have to use the power rule here. So that's negative 2 times x to the power negative 3. Okay, so I brought the old power down and decreased it by 1. Okay, so then I have to add to that the second function times the derivative of the first. Okay, and probably need a little bit more room here. Derivative of the first function is 5x to the 4th. Okay, I should use the power rule, minus 6. Right, the derivative of 6x is 6. Okay, so basically all I need to do here is simplify. So I've got x to the 5th minus 6x, okay, times, let's write that negative 10 x to the negative 2, okay, plus 5x to the negative 2 times 5x to the 4th minus 6. Okay, so now I can multiply through. I'm going to get, let's see, I have to distribute this term into the parentheses. That's going to be negative 10, okay, but then I have x to the negative 2 times x to the 5th. So if you remember, whoops, oh, I'm sorry, that's negative 3 there. Whoops. Okay, x to the 5th times x to the negative 3rd. So we add those powers, and I get negative 10 x squared. 5 plus negative 3 is 2. Okay. And then I multiply these terms together and I get negative, positive 60 x to the power negative 2, because that's x to the power first. And when I combine those, I add the powers. Okay, and I got to distribute here. So I get 25 x to the power, it'll be positive 2, right? I'm just multiplying the first term with the 5x to the negative 2 times 5x to the 4th. Okay. And then I have minus, that'll be 30 x to the negative 2. Okay, so this is going to be negative 10, whoops, sorry, now I can combine terms, I guess, so what can I do here? Well, that'll be, it looks like 15 x squared plus 30 x to the negative 2. So for the final answer on this one, I could probably write 15x squared plus 30 over x squared, and that's what they would want in the book on this one.